point. 6-1 and 6-2. 6-1, remember, was solving by graphing when you have two equations. 6-2 was solving by substitution. You take something out, you put something of equal value in. Today we're solving by elimination. So today you are eliminating a variable so that you can solve for the other variable. This is probably my favorite one of the three. You'll have to judge how you feel about them. Maybe I should make you rank them. When we're done with this lesson, you're going to rank for me the order of how you like graphing, substitution, elimination. I personally like this one the best. So your questions are going to look exactly the same as they did before. You're going to have two equations, a system of equations, right? That means two or more equations. And they're going to say, use elimination to solve this system. So you're still going to get an answer that's a point, an x value and a y value. It's just that you're going to go about it a different method now, okay? Just so you know, on this test, I'm very specific as to when you get to solve which way, because I want to see that you can do all of them. So even though you could maybe solve it with substitution, I'm going to ask you to do elimination, okay? Or vice versa. So you need to be able to do all three of these, okay? Here's how it goes. You will have one equation, 2x plus 5y equals 17. And you'll have another equation, 6x minus 5y equals -9, okay? Now, when you were a kid, you learned how to do addition and subtraction vertically. Remember where you would do like 15 plus 6, and then you would solve that, okay? So 5 plus 6 is 11, carry the 1, so you get 21, right? If I did 16 minus 9 vertically, you're going 6 minus 9 you can't do, so you borrow. This is now a 0. 16 minus 9 is 7, okay? You worked vertically. Is that coming back familiar? You used to doing that? Good with that? Okay, you've done it a lot in my class too, just not with straight numbers like that. What you're going to do today is that. You're going to be working vertically to get a new equation, okay? So here's how it goes. This is your equation bar, and we are going to eliminate a variable. So if you look at this, we have a 2x and a 6x on the left, and then we have a positive 5 and a negative 5y. When they are opposites like that, that's ideal. That's where you want them to be able to solve this equation, or this set of equations, this system of equations. So what we're going to do is we're going to add these two equations together. That means if I go here, okay, 2x plus 6x is what? 8x. Okay? Then we go here. What is 5y plus a negative 5y? 0, okay? That has now been eliminated. We just eliminated one of our variables. So you don't need to write plus 0 there. You can just leave it that it's gone. This is 0, okay? Then you bring down your equal sign, and then you do 17 plus -9. 17 plus -9 is 8. Because we're adding the two equations together. So we're doing 2x plus 6x, we're doing 5y plus -5y, and we're doing 17 plus -9, okay? So this is what you're always going to do. Here's the thing. I would say to play it safe, always add. But technically, you can do it using subtraction. How did Mr. Samuelson do it? Do you remember? Do you know, Dylan? Did he say always add? I feel like he usually does the always add way. So I just don't want to throw you off because you're going to do this with him next year. So I want to keep it consistent. All of you will do this same lesson with Mr. Samuelson next year as a review. Yeah, we'll see. No, you guys will do great, okay? It will be great. Okay, so here we go. He will do the same. So here's your equation. 8x equals 8, okay? Your task is to solve that. So if 8x equals 8, you're going to divide by 8 on both sides. So you get x equals 1. Okay? And now this one takes a little bit more work than the substitution way for your next step, just because nothing's isolated in these. So what you're going to do next is you're going to pick either your blue equation or your red equation to plug your x back into. Do you have a preference, blue or red? You can do either. Blue? Okay, so if we go with the blue equation, it's 2 times x plus, don't write this down yet, 5 times y equals 17. We're going to take that x value and we're going to plug it in. So it's going to be 2 times 1 plus 5y equals 17, okay? So keep simplifying. You get 2 plus 5y equals 17. What do you do next to simplify? You subtract the 2. Okay, take away 2, take away 2. So you get 5y equals 15. And now you're going to divide by 5. Should really be taking notes on this, guys. This is a lot of information. So you get y equals 3. That means my answer is 1, 3, right? My x is 1, my y is 3. That would be my answer then. Okay, so I just took my 2 equations and I added each column of my 2 equations. Does that make sense? Okay. That is as simple as they get, where you don't have to change either of your equations. You just leave them as they are and you solve. Okay? Where it gets a little fancier, not tricky, hopefully, is when your 2 equations don't have something as easy to eliminate. So, for instance, your first equation is negative 2x plus 15y equals negative 32. And then your second equation is 7x, not plus, minus 5y equals 17. Okay? So right now, are either your x's or your y's going to cancel out if you add or subtract them? No, they won't, right? So what you have to do is you have to make an equation that will cancel out, okay? So if you look at this, you're just looking for what equation could I multiply so I can easily get the number in the other equation. Well, if you look at this equation, the blue equation, what could I multiply that by so that one of my numbers cancels out? 3. Right? If I take this negative 5 and I multiply by 3, I'm going to get negative 15 so that these two numbers are the same. Okay, so that's what we're going to do. But when you do this, you multiply everything by 3. So I'm multiplying, this is kind of like the distributive property. I'm multiplying every part of this equation by 3. Okay, I'm going to start, before we do that, I'm just going to rewrite this. So negative 2x plus 15y equals negative 32, so that we can write this multiplied version right below it. Okay, so if I multiply everything by 3, 3 times 7x is what? 21x. Okay, 3 times negative 5y is a negative 15y. And then don't forget to multiply by the one on the other side also. A lot of times that's what people forget, is to multiply that 17 by 3. So you go 17 times 3 is 51. Okay. So now if you look at your setup, these two are opposites, which means if we add them together, they go away. It's 0. Okay, so that's what we're going to do. We're going to set it up so that we can add these 2 equations. Remember, you're adding everything here. So you get negative 2 plus 21x. What is that? Negative 2 plus 21.
19.
positive 19, right? Negative 2 plus 21 is positive 19. 15y plus a negative 15y is 0. So that's gone. Okay, that's 0. What's a negative 32 plus 51? Not 21. What is that? That is 19. That's 19. So you get 19 over here. Okay, so now my equation is 19x equals 19. So if I divide by 19 and divide by 19, this reduces to 1. So x equals 1, right? 19 divided by 19 is 1. Okay, now your job is to plug that back into one of the equations so we can solve for our y. And you may plug it into this equation, or you may plug it into this equation, or you may plug it into this equation that you changed it to. I don't recommend using the one you changed it to just because those numbers got bigger. So I would use one of the first two. So if we just use that top one, who needs to turn their sounds off? Turn them off. So negative 2x plus 15y equals negative 32 was the equation. That was my top equation here. We're just going to plug that x equals 1 into the x spot. So it would be negative 2 times 1 plus 15 times y equals negative 32. And then we just keep simplifying from there. Negative 2 times 1 is negative 2 plus 15y equals negative 32. Okay, then we're going to add 2 to both sides. So plus 2 plus 2. What's negative 32 plus 2? Negative 30. So we get 15y equals negative 30. And then we divide by 15. What's negative 30 divided by 15? Negative 2. Okay, so your answer right now is 1, negative 2. Okay, that's elimination. You might have to multiply to be able to eliminate, but that's okay. Questions on that? We're not there yet. I got a couple more examples for you. Okay, third example, and this one again gets a little more involved, which you'll see when I get this setup laid out for you. So you have 3x plus 2y equals 1, and then 4x plus 3y equals negative 2. Okay, so the idea is we want to eliminate a variable. So either get rid of my x's or get rid of my y's. Can you do that with the problems with the equations as they are? No. Do any of them cancel out? No. Okay, so then you have to ask yourself, okay, could I multiply one of my equations to get those numbers to match up? So could I multiply a 3 to get a 4, or could I multiply a 4 to get a 3? No. Not nicely, okay? Same thing here. Can I multiply a 2 to get a 3, or can I multiply a 3 to get a 2? No. No. So what happens is when you can't do just one of them, then you have to multiply both equations so that you get matching numbers, actually opposite numbers. The easiest way to do that is to multiply the top equation by the bottom number and the bottom equation by the top number. Okay, so you can choose, do I want to eliminate the x's or do I want to eliminate the y's? And then just multiply by the coefficient. Okay, in this case, because 2 and 3 are smaller than 3 and 4, I would get rid of the y's, but you don't have to. That's just the way I tend to do it. Okay, so think about it this way. If I'm going to multiply this 2y by something so that I can multiply the 3y by something to get the same number, what's that number that they would be the same as? It's a weird way to say it. What are 2 and 3 both multiples of? What number? 6. Okay, so if I turn those both into a 6, or one into a 6y and one into a negative 6y, then they'll cancel out. Okay, the way I do that is I multiply the top by what? How do I get this 2y to become a 6y? Multiply by 3. Okay, so we're going to multiply this whole top one by 3. And then this bottom one, it would be nice if I can make it a negative 6y so that they cancel out. They reduce to 0. Okay, so what would I have to multiply the 3y by to get a negative 6y? A negative 2. Okay, so I'm going to multiply this whole bottom equation by negative 2 and the whole top equation by 3. Okay, so we're just going to rewrite them. Starting here, what's 3 times 3x? 9x. What's 3 times 2y?
6y.
Plus 6y equals, careful, that's where a lot of people make the mistake, equals 3, right? Make sure you multiply that 3 by both. Okay, so that's my new top equation. Now the bottom one. Negative 2 times 4x is what? Negative 8x. Not plus. Negative 2 times 3y is a negative 6y. And then negative 2 times negative 2 is a positive 4. Okay, so those are the two equations you're going to solve now. You're going to do elimination with these two. So we're going to add them together. So you get 9x plus a negative 8x, which is what? Positive 1, right? 9x plus a negative 8x is just 1x, so you can just call it x. 6y plus a negative 6y goes away. And then 3 plus 4 is 7. So you get x equals 7 to start us off. Okay? Where do you plug that in?
You said where can we or where do we?
Sure. Where can you plug it in?
Either the blue or red.
You can plug it in anywhere you see an x. So you may plug it in here, you may plug it in here, you may plug it in here, or you may plug it in here. If I were you, I would not plug it into the new equations. I would always go back to an original, just because one, if you made any mistakes, then you go back to the right equation, and two, it's smaller numbers. So I would go back, let's just do this first one. Okay, my equation was 3x plus 2y equals 1. So I'm going to plug 7 in place of my x. Okay, so it's 3. Oh my goodness. Turn your sounds off, people. So 3 times 7 plus 2 times y equals 1. Okay, then we simplify that. This is 21 plus 2y equals 1. What do you do next? Subtract the 21. Okay, so this is 0. You get 2y. 1 minus 21 is a negative 20. And then divide by 2. So y equals negative 20 divided by 2? Negative 10. Okay, so your answer is what?
7 and 10.
7.
Negative 10.
Yes. Okay, 7, negative 10 would be your answer. Does that make sense? Any questions on that? So you can do it where you don't have to multiply any of the equations. You only have to multiply one of the equations, or you have to multiply both of the equations. But the process is the same beyond that point. Okay? All right, last thing. Just like we did in the last set of problems, actually in both of them, 6-1 and 6-2, you could have one solution, no solution, or infinitely many, right? Same goes here. If you end up with something that says 5 equals 5, what would your answer be? Infinitely many. If you ended up with 5 equals negative 5, what would your answer be? No solution, okay? So let's say you have this setup. 2x plus 6y equals 18. And x plus 3y equals 9. okay? Can you eliminate, who is that? Is that Micah? Is it you still? Because she's not by it. Your phone's making noises at us. Okay. So if this is the setup, can you eliminate one of your variables right now? 2x to x, 6y to 3y. Can you get rid of it as it is?
No.
You cannot, right? So you're going to have to multiply. Which equation do we need to multiply? Just the bottom equation, right? Because we can make our bottom match up with our top. So we're going to multiply all of this. If we want to eliminate, okay, we want something to cancel out, what are we going to multiply by?
2.
By 3.
Close.
Negative 2.
-2, right? Because we want them to cancel out. So if I multiply by -2, I get, I'm just going to rewrite my top one first, okay? My top one is 2x plus 6y equals 18. My bottom one now,
Negative 2x plus negative 6y equals 9. No, wait. Negative 18.
-18, right. Okay, so now think through this. If I add these two equations together, 2x plus a negative 2x is 0. 6y plus a negative 6y is 0. 18 plus a negative 18 is 0. So we get 0 equals 0.
No solution.
Infinitely many, right? If it comes out to a true equation, that is infinitely many.
Oh, wow.
Okay? If it comes out to 7 equals -3, that's when you say no solution. So just pay attention to what you have. This is not part of that problem, but I just want to make sure you're seeing the setup. Questions on that? All right, you have like 8 minutes.